Happy Lunar New Year. Welcome to Desk of Ladyada.
Hello, this happy dragon welcomes you to the year of the rabbit and the water rabbit, you said
Yeah.
earlier. Okay, well, happy Lunar New Year to everybody. It's a wonderful time of year. A lot of people get to see family, eat some delicious dumplings, maybe get some nice presents in their red envelopes. Here at the Desk of Lady Ada, we are also making delicious dumplings of electronics.
Yeah, we got a lot going on this week.
Mm.
We have some good top secret videos we've been posting up. We just filmed some of those. But this is our live Desk of Ladyada show. So you can ask questions during this, but you can also save them towards the end. We also do the great search brought to you by DigiKey, where we use Lady Ada's power of engineering to find the things that you want to find on digikey.com. Lady Ada, what is on your desk this week?
All right, I'm glad you're. First off, is there any news or updates? I think it shows as usual, right?
Yeah, Liz is hosting or co-hosting Show and Tell, and then we're back doing Ask an Engineer. We were hanging out with some of the Raspberry Pi team on Wednesday, so that is why we did not do a show.
Okay.
Got a lot of cool stuff ahead,
Okay.
especially with Raspberry Pi related stuff.
Sweet. Let's go. Well, speaking of, let's go to the overhead. So this week, one of the projects I worked on is I wanted to make some more feathers. I haven't made new feather boards in a while. And I thought, why revise the feather RP2040? But when I first designed the feathers, I think it's actually one of the first feathers, this one. The way I did it is I, started with a dev board that has USB and charging, and like a reset button, and then I had a main chip, and then the idea was you'd have a different thing over here. So, for example, this is a Bluetooth module, and this is a let's see, this is a 324. Sorry, this is a SAMD21. So this is a Cortex M0 SAMD21. Oh, that's right, it has this crystal. That's how I know. And it's got a Bluetooth module. Here's that same SAMD21. You can see all the parts on the left side are the same, and on the right, it has a SD logger instead. Or this version, also a SAMD21, you can see again, left side is all the same, but this time it's got an RFM, LoRa, or radio module. And then originally this was 32U4 based. 32U4 is good, but I wanted more memory and space. Cortex M0 is a nice update, 32K of RAM. That's still not a ton for CircuitPython or other, embedded interpreted languages, or even if you just want to do like slightly more complicated projects, especially IoT projects. If you're reading JSON data in or buffering data, 32 kilobytes does not last very long. The 7051 is a better bet, and we do have the 7051 here, but it turns out, well, first off, the 7051 is just a larger chip. There's more accessories on there. I could have shoved this over, but because I wanted to basically update the SAMD21 to make it better for CircuitPython use, because for example, the LoRa radio, it kind of uses almost all the memory on the SAMD21. If you want to add other sensors and stuff onto this featherboard in CircuitPython, you run out of memory very quickly. So redoing it with the 7051 would be great, but I can't really get the 7051 right now. It's still like totally unobtainable. And so I thought, you know what? I should just move on and, update it all to use the RP2040. This is the original design of the RP2040 feather in pink. You see, it does take up a lot of space, but that's because you've got this large NeoPixel, and you've got this SWD header and a large SOIC flash memory. But maybe we can make this smaller. If we could make this as small as these SAMD21 feathers, then I could fit, basically the same kinds of accessories, and it would be great for use with CircuitPython, because that's kind of the only, you can use the SAMD21 for CircuitPython, but again, it's a bit of a cramped fit, especially these days, because we have so many things you can do. It very quickly you run out of memory. So to go to the computer. So when I, we got all these feathers, but when I did the Scorpio boards, the Scorpio doesn't have a lot of stuff at the end, but it does, it did have this thing where I kind of tried to squish the RP2040 over to the left to make room for this flash memory and I2C stemma QT port, and then this level shifter. The NeoPixel is smaller. So I took that RP2040 feather and sort of squished everything to the left to make enough room for this 2x8 header and level shifter, so you could use this to drive, 8 channels of NeoPixels, for example. But it's not this zone here is still quite small. I could probably fit one of those tiny micro SD sockets, but it's not large enough for like a bigger radio module. So my project this weekend was to really squish that stuff on the left. And here is what I came up with. So to squish, there's a couple of things you can squish and some things you can't, right? Not everything can get smaller. Oh, this rabbit is kind of in the way. Hi, rabbits in my circuit. This is a cute little, we're going to give this as a gift to somebody with a kid that we know. This little happy rabbit. Happy New Year. Okay, rabbit's out of the way. So the JST connector we can't make smaller. The USB-C we can't make smaller. The LED, there's not really much point in making smaller because it's kind of in this corner here. But and then the crystal, I tried to see, could I get a smaller 12 megahertz crystal? No. 2 by 2.5 millimeters is as small as it gets. The tactile switches, you can't make them smaller. They're pretty much as small as you can get while still being functional. Although I did move the boot tactile button over to the left. It used to be, it was over here on the Scorpio. I moved it over. The NeoPixel, you can make smaller. I made that the 1.5 by 1.5 millimeter, and I kind of tucked it over here. Flash memory, if you want to use 4 to 8 megabytes, you have to use the larger WSON. You can't, or XSON. You can't use USON. The USON is really small. It's 2 by 3 millimeters, but they only go up to 2 megabytes. It actually is like the physical amount of space in the package is required to put that much memory. I also thought about changing the regulators. And well, the charger chip and the regulator, I could change, but I have so many of those in stock and they're not inexpensive. So even though I could have shrunk these down, I was like, well, I think I'll keep them this size for now and I can always shrink them. I did go with smaller vias. These are 11 mil vias. Usually I like to do 15, but I know that it doesn't actually cost more to do 11. It's just, I'm just kind of used to doing 15 mil vias. So I did 15 for the power and ground, but for signal, I went with, I think this is a 7-7 rule, which is, still pretty generous. 7 mils traces, 7 mils distance, and 11 mil vias. And then I did another trick again. I could have gone with a 4-layer board, but 4-layer boards actually do start to cost more money. I wanted to stick with 2-layer because it's not a radio board, so it doesn't, it's not a big deal. As long as I have a fairly good ground plane, I'm not worried about this chip. It doesn't actually draw that much power either. I have a regulator here that's 500 milliamps, but it's actually okay to I think, go with a 2-layer board as long as there's some ground plane on the top and bottom. Underneath the chip, I used this little gap area between the pads and the ground plane to put some vias in to kind of fan out the signals. I'll say if you do this, you'll notice this yellow layer here. That's white solder, silk screen. I do recommend putting silk screen because otherwise you risk the vias. They can short against the ground pad if the ground pad extends out. So whenever I do this little trick, where you kind of shrink the center pad down a little bit, again, it's mechanical, not even really thermal in this case. Do put silk screen in that gap area, also underneath modules. It's just a little bit of layer. It lifts, separates the vias and the ground, but you don't have any issues with connectivity. Like you'll still have all the pads connect just fine.
Okay, some questions. When will we put up the Eagle files for the bones? And then the JST itself, you can't shrink, but you could use a smaller JST or even a pair of pins to reduce the actual board footprint, right?
You could, but then none of our batteries would work, and we've been stocking the same batteries for like 15 years. So I don't really want to change it. I think the Feather standard, you want to have the USB standard and you want to have the JST standard. I like to keep, I don't want to make something different.
Okay, and what about the Scorpio bones files? You're gonna put those up?
The Scorpio files are up.
Oh, okay, great.
They're up on GitHub.
Okay. Next up, there's more. Were you able to sacrifice any of the capacitors recommended in the RP2040's reference design?
No, I actually kept all the caps. But what I did do is I moved them down to 0402. So you'll see that this is an 0402 design. I kept the 10 microfarads as 0805 because the DC bias, derating of a capacitor is affected by the size. The smaller you go, it's not like it's free to go smaller. When you go smaller, the derating increases. And so, I would go to 0402 for one, maybe zero point 0.1 microfarad, I don't mind, or 0.01. 1 microfarad, I prefer to do 0603, but I couldn't fit it. But then the 10 microfarad, I really capped at 0805. I think that's important. You want to have your bulk capacitance and that's the 10 microfarad, and I have like 4 of those. Have those as big as you can.
Okay, and then I've never done a 4-layer board or RF board. Can you explain why 4 layer is better for RF, and which plane order would you recommend?
Check the data sheet for the module or radio they're using because they'll actually tell you exactly what plane order. Usually it's signal at the top and then ground and then power and then bottom signal. But some of them have different opinions about where they want the ground plane. But usually they want that ground plane close by to the signal layer, which is on the top because that's where your traces are. RF, there's nothing inherent about 4-layer that's better for RF. It's just you're more likely to be able to get one solid ground plane close to the traces, which makes it a little bit easier to hit that. If they want a 50 ohm trace to the antenna, or you have a bunch of 50 ohm traces, it's easier to match the impedance if the ground layer is nearby. There's a lot of online JavaScript calculators that'll tell you if your ground plane is this many mils away, how thick your traces have to be, and basically you don't have to be as thick.
Okay, keep going.
So yeah, basically the thing I really sacrificed is first off, I went with 7.7, reduced the vias, put the vias underneath this pad. The big diode that is the pass diode. So the places I could really move stuff. First off, all resistors also, none of the resistors are carrying power. So those all immediately went to 0402s. I would have actually gone to maybe use resistor packs, but turns out like it was actually a little easier to route. I find it easier to route without resistor packs, unless it's just like they happen to be nearby each other. So I stuck with just individual resistors. I feel like if I'm going to pick something up, just have it be all the same. So the place I actually saved a lot of space is here. Like again, there's this bulk capacitance. I didn't want to change those. There's 3 or 4. I think there's 4 10 microfarad caps. There's one on the battery, one on this V high line, and 2 on the 3.3 volt line. Here's the other 10 microfarad cap. So I didn't want to reduce those. And the regulator, I really like the RT9080. I think that it might be possible to get it in a 1 millimeter by 1 millimeter like XFN package. But I kind of wanted to just not do that. I just have so many of these regulators, and like I feel like you actually like I kind of like them as is. I was like, I'll do that last. Like I kind of wanted to get everything else if I could adjust first. So this diode, usually this is an MBR 040, and then I change this to a PMEG 2020. I might show off how I sourced this on the next Great Search, not this week, but next week. Basically, the important thing about this is I want a fairly good forward voltage, maybe, less than 500 millivolts at about an amp. It should pass an amp because this is a power pass, right? The V bus line, this is USB, goes into here, goes into V high. I don't want to lose more than about a half a volt here. So this is 4.5 volts. V bus can be as low as 4.5. This can be 4.2 volts. And then I still have plenty of headroom into here. And also a very small reverse leakage current because this resistor, which pulls down this transistor and keeps the battery line from interfering. Sorry, it doesn't. Sorry, it turns on the VBAT PFET when VBus is gone, but when VBus is here, this is powered, and I just want to make sure that if VBus is off and VBAT is on, this current doesn't back leak into here and put voltage on here. So you know some shocking diodes can have as much as like a milliamp or more of reverse leakage current. You want to keep this low leakage. So I think this is like a 20, maybe 50 microampere leakage, which is very small. It means that this will be a very low voltage. The place I actually pretty much, so I reduced this to this was a SOD 123. It's now I think a SOD 323, yeah, 323F. So a little bit smaller, but still can pass a good amount of current. And you don't want you can't have the package be too small because it does have to pass quite a bit of current. Have that low reverse leakage, have the low forward voltage, and dissipate any current because this could be, you know, an amp easily into here, like spiking. But what I did do is I reduced this. This was originally a SOT 23. If you go to my overhead, I'll show it, the two parts that I changed. So these two here, maybe I'll do the zoom. Can I zoom? Ooh, zoom. Look at how zoomy this is. Um, So this is that MBR 040. This was the large diode, and this was the transistor. So this is a SOT 23. So I basically shrank those down. Those were the, again, all the resistors. These are 0603s, and I changed these to 0402s. But those two parts of the power path, I also managed to shrink while still maintaining the capabilities that I needed. So if there's no questions,
Let's go to Great Search.
I'll go to Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. This is when we use Ladyada's powers of engineering and smarts and decades of using the internet and digikey.com to help you find what you're looking for. Ladyada, what's on the Great Search this week?
This week, I'm looking for a smaller package for a power P-channel MOSFET that I use for the power supply on my feather boards because I wanted to shrink my feather board down to make it a little smaller. And traditionally, I use a SOT 23 P-channel FET, but let's look at what I used instead. So at the computer. Okay, so this is the original feather design that I'm going to shrink down a little bit. This is a standard SOT 23 channel PFET. I use the DMG 3415 or 2305, pretty standard. The important things for me are they can pass a lot of current, so at least 2 amps. Even though in this particular case, it doesn't pass that much current. It passes maybe like, a 1 amp peak. But oftentimes I use this same part in a couple different spots in the design. And so I want to make sure that it still maintains that high spec. It also should have a very low RDS on. Some P channel FETs have like, 2, 3 ohms. I want this to be 50 milliohms or less. I also want a pretty low VGS threshold. So what's the voltage required to turn it on? Should be about a volt or less because I'm dealing with 3-volt logic, and often the VGS is like, spec'd at like less than a milliamp of current. So, I want to make sure that I'm well above that. And again, I want smaller than the SOC 23 I've got here. So, and the other thing like VDS, in this case it's 20 volts. So basically I just want like a smaller version of this. SOC 23 is kind of the standard size for small power transistors. You tend to go that or maybe SOC 223. And then you get into like the power DI package sizes. But SOC 23 is very standard. So I want something smaller, but not BGA, because again, BGA is not great for my workflow. I want something that's like a DFN or QFN or whatever, but smaller and similar specs to this. So this is the part that I tend, I've used historically. You can see why there's a lot in stock. It's a very popular part for many people. 20 volt, 4 amp, SOC 23. Again, about 50 milliohms RDS on. And let me give it a little bigger. Hold on, sorry. 50 milliohm RDS on. 20 volt drain to source, 4 amps continuous. Doesn't need to be 4 amps continuous, but you know, I tend to use this for a couple different things. VGS on is about a volt or less. I don't care as much about gate charge or input capacitance because I'm not turning this on fast. I'm not using this as like a switcher. I'm usually like turning it on, it's keeping it on, or turning it off and keeping it off. So I don't care. The capacitance affects how quickly you can turn it on or off. So you have to pull current on and off the FET capacitor. But in this case, it's not that important. Okay, so let's go for a surface mount. So I'm going to find similar stuff. A surface mount active P-channel MOSFET. The rest of the specs I'm going to just sort of do manually. So let's see what we've got. My internet's a little slow, but hopefully we'll be able to look it up. If not, I will just go to the Oh, here we go. Okay. All right, so let's look at what the specs that are important to me are. So first, I want it to be in stock. Thankfully, the chip shortage has calmed down a little bit. You can actually get some parts. I don't want marketplace components. Wheelhouse, I'm not worried about. Let's see. So VGS, that was something that's important, and you can see that it quickly goes up to 2, 3, 5 volts, especially if you want, you know, the bigger transistors. But I want something again, you know, roughly about a volt or less. So I'm going to select that. For RDS on, you can see, you know, they can get pretty high. I don't want, like, you know, you can see that there's some that are like, you know, 5 ohm or more. I'm going to try to stick to, you know, 50. You know, the one I looked at before that I'm comparing this to was 52 milliohms. So I'm going to keep it nice and small. And I'm going to wait for this thing to update. All right, so now we're down to like 153 options. The drain to source voltage, you know, that's how much voltage you can switch. For this particular board, the Feather, everything is 3 volts. You know, let me try again. For my Feather design, it's 3 volts, but I use this in my Metros that are switching 12 volts. So I'm going to I'm still going to stick with like 12 or more. I think 8's a little low because often I have a 9, I have 9 volts somewhere in my setup. 12 volts is pretty common. And then let me try again to apply. And you can see that there's a lot of SOT23s. This is very common. Okay, so, got those filters going. So next thing is I want to filter out all the SOT23s because, you know, the only thing is I've got about 150 options, 150 results here. And first up is that DMG 2305. Again, that part that I would get the most of. And there's tons in stock and it's low cost. But I want to not have the SOT23 size because it's too big. So let's go to device supplier package. There's also package case. I think I'll do package case. So I don't want any TO SOT23 or TO size chips. These are too big. I'll kind of pick everything above here. Except I don't want the BGA. I don't want the SOT23 variant. I don't want the powered DFNs because those are kind of big. And I don't want the SOICs or TSOPs. But I think the others are good. Let me see if those come up. Okay, great. So now we've got some smaller chips. So the thing is actually each one is they kind of come in like all different sizes and shapes. There's a few common sizes. If you go to the right, you can see the sizes. And some of them, at least, they are pretty clear. Like, for example, this one says 2 by 2, so it's going to be 2 by 2 millimeters. This is 20 by 15, which is smaller. That's 2 by 1.5 millimeters. There's microfet. Basically, let's look at, because now we still have like 66 results, which is less, but it's still, quite a few. Let's look at pricing at 5,000 pieces. So it looks like Toshiba has a couple really good options. Basically, you're going to pay 10 cents for this transistor, which makes sense. It's kind of a nice transistor. There are, a couple different sizes, but it looks like 2x2 millimeter actually is not that much smaller than SOT 25. So what I did is I ended up deciding, I'm going to deselect. So I'm going to select, hold on. I'm going to select all these because these are the sub package types. I'm going to deselect 2x2. So anything that was 20. Because I was like, well, if I'm going to go 20, I might as well go with it's not that much smaller than the SOT 23. So deselect all those. And then this is kind of getting intense. I've got like 15 filters going on here. Another thing I like to do is I like to filter by quantity, and I go down. All right, so now I've filtered, and now oh wait, did I actually do the filter or did I click away? Hold on. Oops, I did not actually filter. 1 second. Let me redo that filtering. So deselect the 2x2 sizes. Okay. Oh, I forgot to click apply all. That's why. All right, let it chug. Okay. And then, so let's apply it. So I had there are two good options that I saw, basically. So one, I liked, this one was kind of nice up here. This is the UFM, which is actually kind of like a SOT 23 size, I think. And the, hold on, let me check. There's still quite a few. Oh, I like the SSM series. That was the one that I thought was kind of interesting. So there's quite a few of these SSM series. They come in a few different sizes. There's also DFN 1616, which was nice and small. UFM, I think, is actually about the same size as the SOT 23. But what I liked is when I started like filtering by quantity available, this actually popped up, which is the DMG 3415 UFY. And the reason I thought this was nice is that I actually already use the DMG 3415 in SOT 23 in the same like situation. Like it's one of my alternative parts that I've used. So this is just the DFN 2.0 by 1.5 version, which means it was basically like swapping compatible. It's just like shrunken down and had little pads. One thing to note though is compared to the DMG 3415, it's slightly less specification. Like it's not identical specifications. But a lot of the important stuff is like, for example, the RDS on is nice and low, 40 milliohms. The gate threshold is 1 volt. The VGS is 8 volts. The only thing to watch out for, because I've used this before, is that means if you're using it as an ideal input diode for polarity protection, the VGS has to be the same as the VDS. So just be aware you can't use a transistor with 8 volt VGS max with like a 9 to 12 volt power supply. But again, for this feather, it's 3 volts, so I'm good. So I ended up really liking this one, and I spec'd it out, and this is what it looks like. So, compared to, this is what the SOT 23 looks like. This is how big it is. And then that's the DFN. So you can see it's like, about a third of the size. The only downside is you can't route a trace through the middle here because there is, well, not without putting down like some silkscreen or and no stop. But this is the thermal pad, so usually you want to keep it open. Also, this gap is pretty narrow here, and I actually made it a little bit wider. So you do have to have like a fairly. You can't use it with a rough PCB process. It has to be like 7 mil, or 6 is better because of the gap is quite small. So I'm using this. I think it's gonna work. I like that it's the same like core part number, and it has almost the same specs. So I think this should let me make this design a lot smaller. I've moved that SOP 23 and the MBR 054 up here and to the right here to clear up a lot of space, and that let me move this crystal to the left.
Okay, it looks like the tiny, looks like it has tiny side pads out. Possible to hand solder, or is it way too small?
I think
with a microscope?
you could solder this by hand, but you'd want to use a little bit of paste and hot air. Check out the last great search for where we cover how to get hot air in a syringe. Sorry, paste in a syringe for doing this kind of hot air or hot plate work.
Okay, that's a great search.
That's right.
Where in the world is that part I need? The great search with DigiKey.
All right, and that's the Desk of Ladyada for tonight. Couple odds and ends before we go. Someone wants to know in one of the other chats, is it possible to program microcontrollers with C Sharp?
Yes, I think there is C sharp. Like the .NET microcontrollers are programmable in C sharp.
Okay, and does our Bones Scorpio board hint towards an Adafruit Feather RP2040 with onboard Wi-Fi?
Yeah, one of one of the modules here is the ESP32 Mini, which you can see on my screen, and that would fit into that spot here as an airlift board. You can see it's actually quite nice. It has like a little bit of space here for some traces and capacitors. The only thing is, you were like, oh, why can't you just use the Pico Cypress chip? I can't get that chip for the pricing that Raspberry Pi can. I can only get the ESP32.
Okay. And then last up before we go, I just wanted to say 3 million thanks to everyone. We are a 100% woman-owned, no VC funding, no loans, no venture capital, open source software and hardware company, and we just hit 3 million orders. Every single order was important and special. So thank you so much, everyone in the community, our entire team. These orders were shipped out by human beings with great pay and benefits and more. And that's one of the things that's been really hard to do. And we're one of the few folks left that do all this. So I just wanted to say thanks so much for being part of it. I reached out to the person who got the 3 millionth order, gave them a nice gift certificate, thanked them so much. And of course, they ordered a Raspberry Pi because we make it possible for people to order Raspberry Pi.
And it's a real person.
It's a real person. So, anyways, I just wanted to say thank you so much, especially for the folks who have just, given us words of encouragement and more, watched the shows and all that. Very much appreciated. And that is our show for tonight.
Bye, everybody.
Bye bye.